Okay guys, we are continuing with area, and so far we haven't really talked about circles, but I'm going to show you in this lesson how circumference and area relate to the arc lengths and areas of sectors. Okay, so reminder that circumference of a circle is the same thing as pi times diameter, or 2 pi r, 2 times the radius times pi. And this is a nice little visual of why that works. So if you think about a wheel, okay, and if I take that wheel and I roll it out, so I've got the circumference of the wheel, and these numbers marked 0, 1, and 2, and 3, these are just the diameters that are measured out. Okay, so that's the diameter of each wheel. So if I do that and I roll it out, I'm going to end up over here at 3.14. So that's 3.14 diameters, or 3.14 times the diameter, whatever that happens to be. So that's kind of a nice image of a wheel rolling out, and we'll use that, that image later on when we apply the circumference. So how does that relate to arc length? Well, arc length is, we're just talking about the distance, or since circumference is the distance around the circle, and for an arc we're only going partial way around the circle, we're only going to do, for our formula, a partial circumference. So the key there is what's the partial? How much of a circumference are we going to use? And this is where we're going to use this angle. So how much that arc length is dependent on how big that central angle is. Okay, if I made this angle bigger, then that arc that corresponds to that would be larger, right? And a bigger fraction of that circumference. So our formula for arc length is simply going to be the measure of our arc, AB, whatever that happens to be, divided by 360. So 360 is the whole piece. That would be like if we were doing the full circumference, times 2 pi r, which is your circumference formula. So this is like, this shows us what fraction of the circumference, and this is the actual circumference. All right, so let's apply that. So in this one, we're trying to find the length of arc AB, and we have that central angle is 40, so we'll take 40 divided by 360, and we're going to multiply by 2 times pi times the radius, which is 12. Okay, so if I reduce this 40 over 360, that reduces to be 1 over 9. And then 2 times 12 is 24. So I've got, so far, 24 pi over 9. And then let's reduce that a little bit more. So 24 over 9, if we divide them both by 3, that'll be equivalent to 8 pi over 3. And I am totally okay with you leaving that in terms of pi. In fact, I prefer it versus a decimal. All right, let's look at this one. We're trying to find the length of MN, and that central angle is 150. So we're going to take 150 divided by 360 times 2 times pi times our radius, which is 24. Oh, I lost that. Okay, 24. So that's gonna, let's reduce this. So the zeros cancel out. Let's divide them both by 3. So that'll be 5 over 12. And then up top I have times 48 pi. And we can reduce this even more. So 12 and 48, let's see. We can divide those both by 6, right? Or can we do something bigger? No. Does 12 go into 48? Yeah, absolutely. So if I divide them both by 12, that'll give me 4 over 1. So this is going to give me 20 pi. All right, so that's how we get the length of an arc. Not the measure, but the length. Okay, so going back to another reminder, area of a circle is pi r squared. And we've been using that, reviewing those basic shapes. But now how does that relate to the area of a sector? So what I mean by a sector is, think of it as a pie slice. right? If I wanted to measure how much area this pie slice takes up, right? All that shaded area, and then that's what we call a sector. So notice it's not the whole circle, it's just part of the circle. So again, if I want to know which part, I'm going to use that central angle again. That central angle over 360 will tell me how big of a piece that is. So our formula for a sector is the measure of AB over 360 times pi r squared. So notice in these directions we are going to find the arc length and we're going to find the area of the sector. So let's do that for each of these. So in this one, I've got 54. So let's do the arc length first. So we're doing the arc length of BC. That would be 54 over 360 times 2 pi r. And we can reduce that. So that'll be 3 over 20 times 10 pi. And again, I want to reduce that a little more. So this is going to be 3 pi over 2. So this is for the arc length. And for the sector, I'm going to use that same fraction. Let's go ahead and use that reduced fraction, 3 over 20. And instead of 2 pi r, I'm doing pi r squared. So this is going to be 3 over 20 times 25 pi. And I can reduce that. Divide those both by 5. So I'm going to get 15 pi over 4. And this would be the area of my sector. Okay, so that's the gist of how we do that. All right, let's do one more. Let's do this number 6. The reason I want to do number 6 is because the central angle they're using is greater than 180. So you see how that's 288. So if I wanted to find this arc length, so let's say I was doing the major arc, KML. All right, we would do 288 over 360 times 2 pi r. All right, so we're going to reduce that 288 over 360, and that'll give us 4/5. Up here, we're going to have 24 times pi. 24 over 5 does not reduce, so all we do is just multiply that out. So that's going to be 96 pi over 5, and that's for my arc length. All right, so then let's do the area of the sector. So I'm going to take that 4/5 again, but I'm going to multiply it by pi r squared. So that's pi times 12 squared. So that's going to be times 144. And 144 over 5 does not reduce. So all we do is multiply that by 4, which is going to give me 576 pi over 5. Beautiful answers. Just leave them in pi. Okay, I'll let you guys do that middle one. All right, let's look at this one. The tricycles. The diagram shows 2 tires from a tricycle. And so they want to know how many revolutions, how many times does it go around in a circle, does each tire make when traveling 250 feet. We're going to round answers to 1 decimal place. So here we're not going to leave them in terms of pi. So if I think about if this is rolling on the ground, that's like that wheel that in the beginning of the lesson that was rotating, how much would that trace out? So we're really talking about circumference, right? 1 circumference is equivalent to 1 revolution. Okay, so for the big tire, our circumference is going to be, see our diameter is 20, so that's just going to be 20 pi. And then for the small tire, our circumference is going to be 16 pi. So let's get what those are as decimals. So this is roughly 62.83, and this is roughly 50.27. So what do I do with that? That's how long it takes that's how many feet it will travel after one revolution. So if they want to know how many revolutions they make when it's going 250, what are we going to do? Well, we're going to take 250 and divide it by the circumference. Okay, so we're going to do 250 divided by 62.83. That's giving me 3.98. And it says to round answers to one decimal place. So I would actually round that up to 4.0. So 4.0 revolutions for the big tire. And then for the small tire, we would do the same thing, but for its circumference. So we're doing 250 divided by 50.27. And that's giving me 4.97. So again, if I round that to one decimal place, that rounds up to about 5 revolutions. And that makes sense, right? It makes sense that the small tire would be turning more often than the big tire. All right, then let's look at this one. We're trying to find the area of the shaded region. And notice that this area is everything except the white part. So I'm basically going to take this rectangle and I want to subtract the white area. So those are sectors. So here's our plan. Area of the rectangle minus 2 of the area of the sectors. Because notice that these are congruent sectors. They're vertical angles, so they're going to have the same measurement, same area. So the area of the rectangle is 12 by 8, which is going to give us 96. And then the area of the sector, that's the new part, we're going to be doing our 108 over 360 times pi r squared. So now we just need to figure out what r is. What would be the r? Remember, the r is going from our center out, but I don't have any labels for that. Now keep in mind that I could draw a radius like that. I could draw a radius like that. So we already know that the vertical height of this figure is 8. So that would mean each of these has to be 4. So my radius is 4 there. So let's figure this out. So 108 over 360, that reduces to be 3/10 times 16 pi. And let's see, let's do this all at once. We're doing 2 times 3 times 16 and reducing that over 10. So this is going to be 48 pi over 5. So I'm okay if you write your answer like this. These cannot combine, okay? This has a pi in it, this does not. So I'm okay if you leave your answer like that, or you can get a decimal. But if it says exact answers, then leave it like that. All right, so let's look at this one. We've got, this looks more like what we were doing in the last class. We've got a rectangle, and we're going to subtract off the square and the semicircle. So this one's kind of nice because I've got a semicircle, so I don't really have to worry about the sector. It's just half of a circle. All right, so the rectangle is 36 by 26. The square, it looks like, I'm assuming that 16 is that whole diameter, so it looks like the square is 16 times 16. And then the semicircle would be 1/2 pi r squared, and the radius would be 8. So let's do some calculations. This is going to give me 936. This is going to give me 256. And this is going to give me 64 divided by 2. So that'll be 32 pi. And then let's combine the 936 and the 256. So I'm going to have 680 minus 32 pi. Oh, and they want us to round to the nearest square foot. So here's an example of where we do have to actually do the decimal. And I would suggest using your pi button on your calculator. So that's 579.47. So 579 would be my answer on that one. Okay, so it really just depends on what the question is asking or what you need it for. Okay, let's do this last one. So the area of this one, we've got area of a semicircle plus the area of the triangle. So we're going to have, again, this looks like this is 7, the diameter is 7, so that means that the radius is 3.5, so that's going to be 1/2 pi r squared, plus, for triangle, it's 1/2 base times height, so 1/2, 7 times 7. So here, let's go ahead and, since we have decimals, we'll go ahead and get decimals for all of that. So this is 19.24. This is 24.5. Add those together, and we get 43.74, okay, meters squared. All right, so that's approximately what we're getting there. Now this next one says find the perimeter. So again, we're basically doing half the circumference of the circle, plus we're going to do this line, that's a 7, plus this line. So we need the hypotenuse, right? And then here will be the circumference part. So let's do the circumference. That's going to be, remember, pi d, so that's 1/2. Pi times the diameter is 7. And then we had the 7 from the top part. Over here, let's go ahead and do, if you remember, 45, 45. We know that this is going to be 7, 7, and 7 square root of 2. Otherwise, you could have done Pythagorean theorem. And that would give you 98 over here, which if you take the square root of that, will give you 7 root 2. So this is going to be 7 root 2 for your hypotenuse. All right, so we have 3.5 plus 7, so we have 3.5 pi plus 7 root 2. And if we were doing exact answers, we could leave it like that, but let's go ahead and get a decimal. So 3.5 pi plus 7 root 2. And I'm getting about 27.9. Alrighty then, we'll do some more practice in class.